Hey everyone, so my name is Naja binti Mohammed Nasir. And my matrix number is U2101524. So today I'll be presenting about the Mosfet application in biomedical field. So the medical device that I have chosen is transcranial magnetic stimulations. So the picture attached on the right side is the structures of the MOSFETs and the device of the MOSFETs. Moving on, so in this presentation, I'll be talking about the basic principle of the MOSFET, the operations of MOSFET, the applications of MOSFET in biomedical field, and also the summarization of the applications of MOSFETs. All right, moving on to the introduction to MOSFETs. So as you all must be wondering, what are MOSFETs? So MOSFETs are actually transistors. They are semiconductor device that either act an electrically controlled switch or a signal amplifier. So it comes in a variety of shapes, sizes, and designs. But transistors falls under two major families, which are BJT and also FET. So what MOSFET stand for? So MOSFET stands for metal oxide semiconductor field effect transistors, and it falls under the type 2, which is the field effect transistor, which is FET. So MOSFET has three terminals, which are sources, gate, and also drain D. So MOSFET acts as a voltage controlled resistors when there is no current flows into the gate terminals. And also, the voltage at the gate, which is here, determines the current flow between the sources and also the drain. And the differences between the BJT and FET is that in BJT, both minority and majority charge are involved. But in this FET, only majority charge carriers are involved, whether it is positive or negative. Okay, MOSFET transistors are mostly used in the circuit applications. Moving on to the next one is the type of MOSFET. So there are two types of the transistors of MOSFET, which is the first one is the depletion type. So the depletion type MOSFET is normally a closed switch. This is because it requires the gate source to switch off the device. So as shown here is the symbol of the MOSFET symbol in N channel and P channels. So here we can observe that the fault terminal, which is the substrate, is connected to the ground, which is the source, as shown here in the P channel 2. While the next one is the enhancement type. So the enhancement mode MOSFET is equivalent to normally open switch, which it requires a gate source voltage to switch off the device. So as shown here is the symbol of it. So we can observe that there is a broken line here, which is connected to the from the drain to the sources, and the same happens to the P channels. All right, moving on to the functions of MOSFETs. So what are the functions of MOSFET? As I told just now, it have three terminals, right? Which is the sources, gate, and also drain. So the function of it is to control the conductivity or the electricity flow. Well, the next one is used as a switch to turn on and off another circuit, like I told you in the depletion type and also enhancement type of the MOSFET. The next one, it acts as a power MOSFET to control high power circuits. And lastly, it is also used in computer memories. All right, the next one. So for the device that I have chosen, it is transcranial magnetic stimulations. So on the right, this is the diagram of the device that I've chosen, which how it actually carry out its function. All right, what are transcranial magnetic stimulation? So TMS, which is transcranial magnetic stimulation, is a non-invasive way to stimulate the brains. So it can be a form of therapy to treat people who have mental illnesses. So it is a solution to treat people with mental disease like depression or Alzheimer's disease. So this is one of the many reasons why continuing to develop this transcranial magnetic stimulation is very necessary. So what are the MOSFET functions in this medical device, right? So MOSFET acts as a control switch to stimulate neurons in the brain. So in this medical device, high power electromagnetic waves are required to perform its function. Like shown in the picture here, the waves are required to actually carry out its function. And also, special circuit is required to generate the magnetic wave. So the next one. So as shown here is the circuit diagram that is very important to conduct the functions of the medical device, and it involves MOSFETs in the applications. All right, moving on to the functions of MOSFET in this medical device. So MOSFET was used in the circuit, and the gate of the power of MOSFET is actually triggered through an external function generator. And also, there is a coil connected to the MOSFET in which the coil connected will emit the electromagnetic wave needed for the transcranial magnetic stimulation to treat the disease and detect any disease in the brain. And also, to continue the function of MOSFET, there is a flyback diode to prevent the MOSFET from frying when it gets turned off. So now we can see that the power of MOSFETs is very important in the medical device such as transcranial magnetic stimulation, as it is used as a power to conduct the functions of the device. So, as a conclusion, we can see that MOSFET sensors are widely used in biomedical application, and it is very important to treat and diagnose mental disease, important to stimulate nerve cells in areas of brain known to be associated with major depression. And so that's the end of my presentations. So these are the references that I've used in the slide to make this presentation. And lastly, thank you so much and enjoy your presentation. Bye-bye.